We are going to see now the reactions of alkanes. The reactions of alkanes are three. The first one is going to be combustion. The combustion is burning something, and we know that all the alkanes are fuels. That means that they can be burned. So if we have an alkane and we burn that, means combining with oxygen, is going to be giving us carbon dioxide and water if the combustion is complete. You don't need to know the incomplete combustion right now. But if the incomplete combustion is present, instead of carbon dioxide, we are going to use, or we are going to obtain carbon monoxide instead. For example, when we burn the gas in the Bunsen burner, the reaction is going to be methane plus oxygen to give us carbon dioxide plus water. Now, we need to balance that equation. So the first thing that you are going to balance always is the carbon. So we have one carbon here, they are balanced. We have 4 hydrogens here and only 2 here. So if I put 2 waters, that is going to be balanced as well. And the last thing is the oxygen. We have 2 oxygens here. We have 2 here plus 2 in the water. That is 4. So a 2 here is going to balance the equation. That is the only thing that you need to know about combustion. The next reaction is going to be the substitution reaction by a halogen, and that occurs only in presence of UV light. These reactions do not occur in darkness. So first of all, which are the halogens? Well, halogens are elements in the group 7, like fluorine, chlorine, bromine, and iodine. Those are the halogens. So what is going to happen is that the halogen is going to react with the hydrogens in the alkane, and is going to be replacing and forming the hydrogen halide. We are going to do one of the examples with chlorine. And if we have methane, plus chlorine gas, I'm going to put it in green so you understand. Chlorine attached to chlorine, and I'm going to put it separate so you understand exactly what happens. So one of the chlorines is going to replace the hydrogen, and the hydrogen is going to take place of the chlorine. So basically what we are going to have afterwards is the chloroalkane, in this case methane, chlorine, plus hydrogen chloride. How do we name this compound? This is called methane. This is chlorine gas. This is chloromethane, or methyl chloride. And this one is hydrogen chloride. This is a very useful reaction because the alkanes are not very reactive, but the haloalkanes, when a halogen is attached to an alkyl group, is going to be very reactive, and we can then substitute this chlorine for OH to obtain an alcohol or any other things that we can do with the haloalkanes. The last reaction is cracking. An alkane. Why cracking is necessary? Why? When we do the fractional distillation of crude oil, most of the compounds that we have a lot of carbons in the molecules. Means that they are very big molecules and they are not very useful in industry. What we need are small molecules that are more useful. That's why we need to break the compounds in smaller compounds, and that is basically what cracking is. So cracking is breaking a big molecule into smaller compounds, and at least one alkene is going to be formed, and double bond will be formed. We are going to see how exactly. I can use a very big molecule and show you a very complicated way of doing that, but it's going to be more easy, a lot easier if instead of doing that, I use a smaller molecule. For example, if I have hexane, 1, 2, 3, 4, 5, and 6. The method that I'm going to show you is not exact method, but it's going to help you to understand exactly what it is and how it works. Now, what is going to happen is that this molecule will be broken into two. Let's say that it breaks here. One of the molecules are going to be very small at the beginning, okay, and ethene is most of the time obtained. Now, this hydrogen that is here is going to be attacking the carbon here. So what we are going to have is carbon 4, 1, 2, 3, 4, then all the amount of hydrogens plus one more that is replacing this carbon here. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hydrogens. Now, what is left is this part here. That is what is left. And that is two carbons with 4 hydrogens. So it's going to be carbon, carbon, 1, 2, 3, 4, hydrogen, 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 and hydrogen. We don't have any more hydrogens, so we need to do something. Actually, a double bond is formed. So what we used to have as hexane is going to give us propane plus ethene. And this has the double bond. Okay? In general, if we add the carbons and hydrogens in one side, they have to match the carbons and hydrogens in the other side. That is very useful because many times in your exam you have to calculate how many carbons are left after one of these is produced.